In this warm-up, you are just multiplying the values together. I'll do number 4, since those are the ones with the most digits. So we're going to multiply everything by 5. 5 times 5 is 25. 5 times 4 is 20, plus 2 more makes 22. Then we're going to multiply everything by 0, but since we're moving to the tens place, we need to put a spacer there so that we line up in the tens place. 0 times 1 is 0, 0 times 5 is 0, 0 times 4 is 0. Then since we're moving to the hundreds, we need 2 spacers so that we line up in the hundreds place. 2 times 1 is 2, 2 times 5 is 10, 2 times 4 is 8, plus 1 more makes 9. 5, 5, 4, 2, and a 9. So 92,455. Please complete the remaining 3. Here we see Sasha's work for 365 divided by 5 and Toby's work. This is the strategy we saw in the previous lesson where we looked at how many tens could fit into 365, and Sasha started off with 60. 60 times 5 was 300, so she subtracted, and she realized she could fit another 10 fives in there, which would be 50, and she subtracted, and 5 times 3 is 15, which 60 plus 10 is 70, plus 3 makes 73. Toby, on the other hand, used the standard algorithm or regular long division for his problem. 5 does not fit into 3, so we don't put anything here, but 5 does fit into 36, and it fits in 7 times. 5 times 7 is 35. Then we subtract, and we bring down this 5 here. 5 fits into 15 3 times with nothing left over. For problems 1 through 5, divide. As necessary, express quotients as mixed numbers. So I went ahead and I created a list of the multiples of 19 just to help me as I'm going through. Okay, so I like to use a list of 9 because that allows me to use all of the digits 1 through 9. Now in this problem, we put the 6,194 inside and the 19 outside. 19 does not fit into 6, so we skip this piece here. But 19 does fit into 61, and we see there's a 57 here, which is 1, 2, the third in the list. And that was 57. Now we'll regroup. 11 minus 7 is 3. Then bring down the 9. It's very important that you keep your division organized so that you don't make any silly mistakes as you go. Which I already did. 11 minus 7 is 4, not 3. Okay, 19 fits into 49 twice, which is 38. That gives us 11. Then bring down the 4. 19 fits into 114. This is the 1, 2, 3, 4, 5, 6th one in the list, with no remainders, so our answer is 326. All right, for number 2, we have 802 divided by 32. Again, it's helpful to create a list. I see that I've already passed 80. 32 does not fit into 8, so we're skipping that one. But 32 does fit into 80 2 times, which is equal to 64. We will regroup. 10 minus 4 is 6. 7 minus 6 is 1. Then bring down the 2. So we're going to have to continue on in our list. And it appears that it can fit in 1, 2, 3, 4, 5 times for a total of 160, which leaves us with 2. Our answer here, since 32 does not fit into 2, is going to be 25 and 2 over 32. You can also reduce that to 1/16. Both of these answers are correct answers. One is just in the reduced format. Four fits into 4 one time. And that leaves us with 0, so we can bring down the 8. 4 fits into 8 2 times, which is 0. So we can bring down the 0. 4 fits into 0 0 times. But 4 fits into 9 twice. 4 times 2 is 8. That leaves us with 1. So this is 1,202 and 1/4. So 143 doesn't fit into 3. It doesn't fit into 34, but it does fit into 343. And it fits in there 2 times, giving us 286. We will need to regroup. 13 minus 6 is 7. We'll regroup here as well. 13 minus 8 is 5. And 2 minus 2 is 0. Then we'll bring down that 2. Looks like we might need to continue in our list. If I add a 3 to 9, that gives me 12. We would carry the 1. 4 plus 2 is 6, plus 1 more makes 7. And then 100 plus 400 is 572. So that is exactly 4. So our final answer here is 24. All right, so we have 55,233 divided by 51. 51 does not fit into 5, but it does fit into 55. 5 minus 1 is 4. 5 minus 5 is 0. Bring down that 2. 51 does not fit into 42, but it does fit into 423. It'll be this one, which is 1, 2, 3, 4, 5, 6, 7, 8 in the list. We'll regroup. 13 minus 8 is 5. 1 minus 0 is 1. 4 minus 4 is 0. Bring down this final 3. That's the third one in our list, which is 0. So this is exactly 1083. So another method we can use to find the greatest common factor is called the Euclidean algorithm. And Euclid was a famous mathematician who came up with this pattern or this process to find the greatest common factor. So we're going to start with 840 inside and 660 as what we divide by. Now that fits in there one time. If we subtract, regroup here, 100 or 14 minus 6 is 8. 7 minus 6 is 1. I'm going to draw that in a different color though, so you can kind of see the process that's going on here. So now I'm going to take this piece and it's going to go inside, and I'm going to divide by the remainder. So 18, we can create a list of those. 180, 360, 6 plus 8 is 4. We would put the 1 here. 1 plus 1 is 2, plus 3 would be 5, so that would be 540. So it fits in here 3 times. Let's use a different color here. 6 minus 4 is 2, 6 minus 5 is 1. So now the 180 is the internal piece, and the 120 is what we divide by. That fits in there one time, leaving us with 60. 120 goes inside now, and 60 is on the outside. 60 fits into 122 times, and that gives us 0. So when we get 0 as our leftover, the greatest common factor is the piece that we were dividing by. So in this problem, the greatest common factor of 840 and 660 is 60, because this is when we got that remainder of 0. So we would continue this process of swapping the outside to the inside and the remainder to the outside until we get a leftover that is equal to 0. It's just a different process for finding the greatest common factor, but if you prefer the trees or the list of factors, those are still valid ways to get to the answer. So just make sure that your warm-up is finished and your workbook is filled in for this lesson.